Hi there folks, and welcome to this episode of Michael's 3D World. Have you had problems printing ABS or ASA type printer filaments? Not everybody's printing that type of material. A lot of people are just using PLA. But if you want something that's going to hold up for outdoor use, or that needs UV protection, or is going to be exposed to possibly oil or gas or something like that, fumes that you want to stand up, or something you're making that maybe goes inside your car. Because you'll know this, if you put PLA stuff and you leave it in your car, it will turn into a potato chip basically. It'll warp, it'll melt in your car because interior car temperatures get pretty warm and it will distort your product. And you may find yourself wanting something that's a little more durable. That's going to be when ASA or ABS or any other type of filaments along that line, well, they run at a higher print temperature. They run at a higher bed temperature. You run at bed temperatures of 100 degrees Celsius. You're running at print temperatures upwards of 250 degrees Celsius. You're going to need to have a closed environment to make this happen. Now, there has been some people having success with open frame printing, but more failures than a success in my opinion from what I've seen. An enclosure is everything to maintain, so there's no drafts, and you can have an elevated printing temperature environment because these things are giving off a lot of heat. If you could trap that heat and stabilize that environment with that heat, your success is going to be much greater. I'm going to show you what I'm doing to get my Ender3 V2 so I can print ABS and ASA consistently. Let me show you some of the failures that I've had and things I'm trying to correct with this process. Now what I've done here, and I'm hoping, I don't know if you'll be able to see this, right here is one of the parts that I printed. This is red ABS. And there is a slight crack right through here. Well, when you got that crack in there, and you can see this hole on the end is supposed to be round, that doesn't look very round to me. Well, what happens when you print in this open air environment is you get more shrink sooner than you expect to have. And here's another failure that I've had. I printed this one upright. It was tight. Look at that. That is so tight and so perfect right there. And then it started to shrink. And then it started to delaminate. I think if I had a closed environment, this would have come out absolutely perfect. And not to mention the strength it would have. Like this has no strength, obviously. It was delaminated on the layers. You can see the warpage that was starting to happen. And once it started warping up like that, it caught the nozzle, broke it loose from the table, and so on and so forth. Anyway, so I decided to make an enclosure. And I'm making an enclosure that will require virtually no tools other than your 3D printer and a utility knife. And you guys are going to think, this is so simple. Now, if you guys leave comments, it drives my wife absolutely batty when people go, that's genius. Because she goes, do you realize I have to live with this guy? Why do you keep calling him genius? Well, I'm not a genius. I just have some good ideas every now and then. Anyway, if you guys leave genius in the comment, that would be so much appreciated and awesome because my wife does follow my channel and she does look at the comments that people leave and it will drive her absolutely batty. I would love to get like several hundred genius comments on this one particular item alone and give me the thumbs up. I'd much appreciate it, but it'd be hilarious. So let me show you what I designed and what I developed, and I'm putting it together now. This is first time run through. This isn't something that I've built before. And go, hey, this is how I did it, I've done it 100 times. That's not that at all. This is me coming up with it out of my head and putting it together out of some 1/8 inch plexiglass and my 3D printer, a utility knife, and some silicone, clear silicone. And I think it's going to turn out pretty good. So let's look at it. Okay, let's come around here to the enclosure. And you can see these parts that I've printed. All these will be in Thingiverse. I'll put all these components here in Thingiverse. Now what I'm doing to hook this together is I've got this White Lightning Storm Blaster all-weather construction sealant. And it's really thick. And I'm putting it on like right here. The way I'm using it to install this to hook it all together. I'm just filling this up right here. This stuff's really stiff. Once I fill it up like that, as you can see here, the nice thing about the way my design works here is these things don't have to be cut perfectly the same, but close. Close is good enough. And we slide it together. Just like that. And we'll let that set up. I've already got the other 3 corners done. And now you can see here, that I have these top pieces here. I printed off like 12 of these for the top. I probably need a couple more, it looks like. But the nice thing is about this, if you don't have it cut perfect, and I'll show you around over here in closer detail. Alright, as you can see here, when this is pushed down against the top of the piece of plexiglass that I cut, as you can see, I didn't cut it exactly straight and square and perfect. But what I can do here, because I printed these things about 15 millimeters deep, I can actually put them on there so they look like I did a perfect job of cutting. So what I'm going to do is I'm going to put the same silicone on here. I'll back it up here just a little bit here. And I'll show you what I'm going to do. So we're going to squeeze out the same silicone bead. And I want to make sure, I want to strike this off smooth so there's nothing sticking below right now. And then when I put this on, well, I'll use a straight edge. I got this nice piece of plastic that's a straight edge I can lay right on here. And see now, when that cures, it's going to be perfectly flat across there. We'll do this for the next piece too. We'll do this all the way around the top. Bring it over there till it touches that one. There again, look at that. Makes it look like you did a perfect job. Now, because my printer was only so long, I can only print these just so long, so I did them in sections. I'm going to have a gap right here, as you can see. What I can do there is I'll measure that gap, and I'll print me some pieces that fill all these gaps as they're created around there. And then it'll look like it was one solid piece, or close to one solid piece, that goes around the top. So I'm going to finish gluing these together. And as you can see here down on this part here, now this has still got the protective paper on the plexiglass, but you can see here I've created a hinge with doors. And it probably works out better that I left the paper on so you can see it. But these doors swing clear out of the way for me. And we can close it right up. I'm going to print me some hinges. Not hinges, some door latches. I actually might print this bottom piece here, which I think would be really cool if I printed it so it had a stop that I went up against, and then I could put magnets on the back of these stops. And I could have magnets that come together, magnet and a little plate that I could put there so it snaps shut. Well, we're still deciding on what we're going to do there. Well, when I get there, I'll share that with you. But as you can see, it's starting to come together. I got my double door hinges here. I'm going to print the same black pieces for the bottom, because the bottom has an air gap down here of 3 millimeters, because that's what I left here. I might leave it without the gap, let some air be able to get in there. Obviously, we got to circulate a little bit of air. Don't want your computer boards and stuff getting too hot. But I think what I'm going to start off with is what you see here. And I'll monitor the temperature inside, and I'll show you how I'm going to do that. I bought these off of Amazon. They show the humidity and they show the temperature, and you can also hit the little orange button on the back and it'll change it to Celsius. But I made printed a little holder to hold them, so you can see now I've got one in Celsius and I got one in Fahrenheit, and the humidity is plus or minus 5%, it says on the ad. which that's fine for me. But at least you get to know what the humidity is that you're running in your room. And then you also can see, I'm going to look at the ambient temperature, because right now it's like 72.8 and or 21.3, 23.1 C. Once I put this inside in the box when it's running, I'll be able to see how warm it's getting and maintaining inside the enclosure. Now that I've got all those set in place, I can take my caliper that I left out in my shop. Now that we've got these in place and I've got the gaps established, I got 4 gaps. Now, yes, I could have possibly, well, not really, because the machine would only go so big for me on this particular one. So this is as long as I could make them. They were 200 millimeters long, and obviously I need a little more than that. But this is really easy. This is pieced together. I'm also looking to this, with these in place, this plexiglass won't be so flexible. It'll actually give it some rigidity up here, which is great. Not that it needs a lot. I'm going to cut another piece of plexi that just sits right on top here and seals everything off. It's not airtight, obviously, but I think it's going to trap enough heat that it'll make a difference. Let's get on the Fusion 360 and draw me up some more of these. I got 4 varying lengths that I need to create. We'll throw those to the printer, get those printing, and get the top glued up, and the top will be done then. Let's jump on there right now. Now I'll start off by saying I'm not expecting this to be a drawing lesson, but I'm going to show you how quick and easy we can, and there's different techniques you can use to draw these different things as well. What we've got here, on those pieces that are on the plastic enclosure that I've got as a top, they're basically 13.175 millimeters wide. And the reason they're 13.175 is because 3.175 is the equivalent of an eighth of an inch. And I allowed for the eighth inch, and for easy math, I just added, made these things eighth inch plus, made them a total of 13.175 millimeters wide. And they're also 13 millimeters tall with a 3 millimeter base across the bottom. That seemed to work out pretty good for what I did. Now, the cool part is if you know how to draw your own stuff, you can go ahead and make them however tall you want. If just depending on how badly you cut your pieces, I would suggest print all the corner pieces first, put it together, see how badly your cuts are, and then you can make adjustments from there. If you can't make it right, make it adjustable. As one old boy I used to work with used to say that all the time. I loved it. Anyway, let's start off with a sketch here. I'm going to show you one method. We're going to go ahead and pick a surface here. We're in a view, and we're going to look at the top view, as you can see up here. This isn't designed to be a drawing lesson. This is just going to be a drawing how I did it. So we know that the rectangle is 13 by 13.175. So what we can do is we can create a 2-point rectangle real easy. Just sketch it out and see how it automatically has that height there. I want that to be 13 tall. Hit your tab button, and we'll make this 13.175. And just like that, we've got our square created. Now let's go ahead and extrude this. This is going to be fun. This is easy. We're going to do a solid extrude, and it's going to show me that I want to go down away from it because I want to draw on this particular surface again. But I need one of them that is 22 millimeters long. So we're going to type in minus 22. Boom, there's your 22. Now I want to go back to this sketch, back into this top view here off this surface. And we got to make our little groove in here. So what I'm going to do is just do this line feature. We're going to pick up like right here. We're going to come down, and we're going to go over, and then we're going to go up. And there we go. We got our line, right? And we're going to go ahead and close this off, just like that. Now, I need to make this a certain width. We can do it this way. I'm going to pick my dimension. Nope, wrong thing. Dimensional. See this one right here, dimension. Huh. We're going to click here and here, drag it down. We know this is 3.175 is what I need it to be. So now we've narrowed it up. And we also know that we need it to be 5 millimeters from this edge. So it's 5. And we also know we want it to be 10 millimeters deep. And just like that, we've got our next shape completed. We're going to say finish sketch. We're going to do an extrude here. And we're going to hit that.
And I like right down here, you grab this and you can just roll this around however you want to look at it. As you can see, I got it, it's going the wrong way. And I want to go through it all here. And we're going to go distance and all. As you can see, that's going to cut that out. And it's in a cut mode versus a, you got different join, cut, intersect, new body, new component, and hit OK. And just like that, we've created our 22 millimeter long piece. Now that's one technique. Let's get back on here and do another technique because I'm going to show you a couple of different techniques just so you can get familiar with drawing different things. The next thing I want to do is we're going to draw it. This is all in line mode. This is going to be crazy. Whoops, where'd that thing go? There we go. Let's bring it up here. We're just going to create a line. Let's just make this shape. We can just do click, click, click like this, and we can just draw the rough shape just with straight lines, and then we can go back and constrain it. And see, now we have roughly the same shape, right? Well, it's not the right size. Let's go back and do, now we got dimensional constraints, we're calling it. And we're going to create this width here. We know that this piece needs to be 5 millimeter, right? Not 50. Double click there again, 5, enter. And we know that this one we want to be 3.175. And then if we constrain this one to 13.175, that's automatically going to make this one 5 millimeter, right? Makes sense? Now we want to make this one, whoops, let's go here. We'll make this one, let me get back to my dimension mode here. There we go. This is 13 millimeter. Now, as you can see, these two didn't move together. So we want to put another strain in there. There's a one called collinear right there. So what I want to do is I want to pick that, hold my control key down, and pick this one, and I want to click collinear. And you see how that brought them down in a line together? And now, see, it's taking a lot longer to do it this way. With these little steps, sometimes you need them, sometimes you don't. That's why I want to show you multiple ways to achieve the same result. Now, as you can see here, we've got our dimensions. We're 13, 13.175, 3.175 wide. This one's done. This is the size and everything we want it to be, right? Let's hit Finish Sketch. And we can select this now. I mean, there again, we can extrude this one. And we want this one to be 23.5. If we rotate this around, we can see that we created one. Now, if I wanted this same front here to be the same as this front, it doesn't matter in this world right now that we're in. But I can go back in here and right-click, Edit Feature, and see how this is 23.5? I can just type in a negative here, and it'll go back the other direction. And see, and I've got the same thing. So now I've got one that's 22, one that's 23.5. Is that what that was? Go back here and edit feature. That 23.5? Yeah, 23.5. So that's another technique. Now, let's go back to the top view. So I'm hitting sketch here, and then I'm going here and I'm clicking this top face so I can just rotate it around for the purposes of what I'm doing here. Now, that was another technique that we used, right? We got the same result. No, we didn't. Something doesn't look right here. Does that not look right? No, it does not. Now I'm going to show you how you can fix that. Cool thing is, we can go back in here onto this sketch and edit sketch. Because something doesn't look right. Oh, you know what? I didn't make this the right depth. So let's go ahead. And this is what's really cool because you've already extruded the solid, right? And this is supposed to be 10 millimeters deep. So we'll click that. We'll type in 10. Boom, you got 10. Hit Finish Sketch. And now it automatically adjusted your solid that you created from that sketch. Slick? Darn right it is. All right. One more. Let's do we got to do another one. I got to have 4 of these. I'm going to see if I can come up with 4 different ways to create this. Now, this one you saw how we drew a cut here. We drew it solid, and then we drew the cut. This one we drew the shape, and then we already had the cut in it, so we didn't have to draw the cut as a separate thing. Let's see here. Let's just do the rectangle one more time. And let's see here. We'll just do a sketch on the top again. And right here, you see me zooming in and out. This is just using the scroll button on my mouse to do that. So you can scroll. So it basically scrolls away and from where your pointer's at. See how it goes toward your pointer. Then if I want it to be on the center screen, I put my pointer right in the middle and scroll in. So there's different ways to do that. And there again, here, I'm going to show you something else here. When you're in this mode right here, this orbit mode, if you're in the center of this circle right here that you see on the screen, and you click right here, you can roll this thing around in all kinds of different ways. You can get yourself lost and confused. Lost in space. All right. So we go back to the top, get them back on the front view here. Boom. Now, if you're in this mode here and you grab it this way, you can rotate it around flat. And then if you're in this mode here, you can grab it up here, you can rotate it straight this way. And if you're in the middle, you can move it in all kinds of ways. All right. Just a little quickie quick there. Now, let's draw another rectangle. Let's see, how do I want to do this one? All right, now we're going to try another method. I'm going to show you another way to create this. And we're going to go to the back view because I want all these to end up sitting in the same position when I'm done. So I'm going to go ahead and go to back, and that's going to bring me to this position. Now, what I've got to create here is I need one that's from here to here is 28.7. So let's go back to our rectangle feature here again. And we'll go ahead and click somewhere in here. Why can't I click? Oh, because I'm in the wrong mode here. Sorry. Let's get rid of that. Let's go back to sketch. We'll do this view. Let's go ahead and put this one right over here. As you can see, these other two are two different links. We're going to do a rectangle again here. And we're going to. Now we want this one to be 28.7. And then this is going to be still 13.175. And we're going to extrude this. I'm going to roll this around so you can see what's going on here. As you can see, this is just some space. It's just in drawing space, no big deal. Now I want to finish this sketch, and I want to do an extrude. And I want to click that. So I need this to be 13 millimeters tall. There, we got that done. Now I need to put the slot in it. So we're going to take a different approach on putting the slot in this time. So we're going to hit our sketch mode, and the cool part is you can select over here, but you want to select it. I want to do a cut from this surface. The nice thing is once you select sketch here, create a sketch, and you select this surface, now everything's going to be drawn on top of that surface, which is really, really slick. There again, I want to do another. And if you see me, when you pick up a corner like this, see that little line? That means it's going to be right on that line. So I want to click there, and I want to come down here and watch it snap to that line. Here again. Just creating that basically a rectangle. Then I want to constrain it with dimensions, right? Because we like constraints. 3.175 for the width of this thing. We already know the length is right because we snapped it to each end, but I also need it to be in the center of this. So now I need to go from there to there, and I need that to be 5 millimeter. Now it's centered. Cool part is we can finish this sketch. It's going to rotate back up, and see I've got a rectangle sitting on top of this. I want to extrude that down. I want to go -10. And there again, we've got the exact same shape, exact same everything, but a different way of doing it. So there's no right or wrong way. It's all in what's your finished product and what you're trying to get to. Now, I would suggest you guys play around with this thing. Try drawing something up in multiple ways because you never know when you're going to need to draw things up in a different method. And that's why I'm taking the time to show you this. You guys can skip past this if you want. If you already know how to draw in Fusion, you don't need this. People that are just now learning to draw, because if you got a 3D printer and you don't know how to draw something in Fusion or how to create it, then your 3D printer is only about 25% effective in your life. When you can actually literally draw anything you want and print it, now you got the world by the horns for sure. Okay, the bull by the horns. Let's see. So now we got 3 different ways. So I got my 28.7. I got one more that I need to do. That is a 25.7. Let's think of another way we can draw this up. 25.7 is what it needs to be. Okay, guys, I had to jump back in. I had to show you one more technique here, which I thought was There again, this is just another way to create this same shape. I'm going to go down here, and now what I've done is I'm creating all these on the same parallel, same line. So when I export it to Cura, it all lay flat on the table. So here again, we're back to the 2-point rectangle, and we're going to go 13 high, 13.175 wide. And then I'm going to do another rectangle right here. So see how it snapped onto here? We'll do this. And then we're going to make that 10 by 3.175. And then you can go in here and hit this trim, little scissor. You go in there and just clip, and now you got the U. Now only thing we need to do is constrain it one more direction, which is this. So we need that to be 5 millimeters. And we got the same thing. Now we can finish the sketch. We can extrude. Whoops. That out. Then we're going to come out 25.7. Whoops. I wanted that to be negative. Let's see, negative 25.7. There we go. Now I've got them all right here. They're all on the same flat plane, so I can export these all at once. All right, we brought all 4 files into the, or all 4 pieces into my slicer, my Cura slicer, and we're going to go ahead and I'm printing, just to kind of give you guys an idea, I'm printing at 210, bed temperature is 60. I've got a retraction distance of 5, retraction speed of 45. These are just all the settings that I've got mine set at. I don't need any support. We'll turn that off. I don't need a skirt. No skirt for this one. No brim, no anything. Just going to let her rip, tater chip. I'm going to play around here because I haven't done a quality of 0.16. I don't need it to be that good. But I'm gonna go ahead and let's slice it and see what it looks. What's gonna tell me it's gonna take? Hour and 47 minutes. You can barely see it here. I wonder if I can move this up some. Yeah, hour and 47 minutes is what it's gonna take. And 13 grams of material. So we're gonna go ahead and let that bad boy print at that level. We're gonna send that to my one printer. So let's do a save to file. So CE gap filler version 1, save, and now we're ready to go print. That's pretty cool. All right, we'll be back after it's done printing, and we'll put them in place.
All righty. Looks like we got all the little spacers printed. Let's go put them on. All right, sweet. We've got all the black on the top. We're gonna let that cure, and then we'll flip it over and we'll work on the bottom and then work on the door hinges next. Well, folks, here's the enclosure in its finished state. I didn't waste a lot of your time trying to show you how I glued the rest of it together, but I will tell you one thing for sure. The silicone I started out with is not the silicone you want to use. I'll guarantee you that, because the stuff never sets up, and it's when it does set up, it's like days later. I don't know if the stuff was old. I bought it brand new at the store, but that wasn't as good as the stuff I had in my caulking gun. So I'm going to show you what I used in my caulking gun. This is the stuff I used. It's an all-purpose silicone, 100% waterproof. Not that that matters inside, but this stuff actually worked really well. It sets up fairly quick. Within a few hours, it's actually skinned over real well, and it's actually gotten quite firm, which is what I wanted to use to make this thing work. As you can see, the enclosure, I'm going to bring you in here close. I'm going to show you some detail here. Don't get too critical of my work. As you can see, the corners I printed, I just used some white. Back this way. I'll have all these things in Thingiverse, at least these corner pieces I'll put in Thingiverse for you. I'll actually put the hinges and the door handles in Thingiverse as well. Not that they're super crucial or critical, but as you can see here, I'll open this door for just a second. But as you see, the door hinges work really great. It all turned out really well. It's currently holding, it bounces between 99 and 100 degrees on that up there at the top. Down here at the bottom, it's holding a temperature, see if I can get the glare off of it so you can see it. It's running about 88.7 degrees Fahrenheit. Like I said, up here was Fahrenheit. It's really cool because the humidity is actually quite a bit less in the box than it is outside because of the heat. It does a great job. I've had really good luck so far. let me show you some of the success I've had printing now that I've had this enclosure around my print. Now this piece here was ASA material, and as you can see, as it was trying to print, it failed. It finally broke it off the table once it warped enough that it actually hit the nozzle there and tore it off the table. But as you can see, it's delaminated, it's shrunk and cracked, it's just fragile as I'll get out there. Now after the enclosure, this is the same material, this is ASA, and ASA is supposed to be better to print with than ABS, but I haven't found that to be the case so far. But as you can see, it's a significant improvement. It's still got some layer cracks, this is still not strong. But then I printed it with ABS, and holy smokes, this ABS piece, I mean, you cannot hardly flex it, much less break it. And I've printed now an entire spool of ABS with unflawed results. It's been printing great. I just did it 2 times. I'm halfway through it here now. 2 times the size, or 200% larger rocket ship that I found on Thingiverse. So I thought I'd print that out of ABS just to see how it turned out, and it's just coming out beautifully. So the enclosure is the secret here. I am running a bed temperature because I'm running this Wham Bam bed. It's a PEX surface, magnetic surface, or the PEX top piece on the metal spring steel. PEX, what is that called? That's some kind of plastic coating, I can't remember. Anyway folks, this is why you know it's real. It's just me, it's not all staged. I don't have a bunch of cue cards I'm reading off of. But I am running at 110 degrees on the bed temp, Celsius obviously, and 240 on the nozzle. And as you can see, I'm not printing with the cooling fan running that's cooling the filament. I'm only doing the fan. The only fan that's running, man, English is tough today. The only fan that's running is the one that cools the thermal break, something like that. You guys know what I'm talking about. Anyway, that's the only one that runs while I'm running this part. And when I'm running ABS, I'm just running no fan up there on top at all. Works great. Does exactly what I want it to do. And on top of that, this material that I'm the bed material here is holding very well. It's repeated and held very well time and time again. Like I said, I printed an entire spool of this stuff. I have printed 6 of these guys, and let's go over here real quick. And I've also printed all the other accessory pieces that go with it. You know, they all work great. These are supposed to snap on here, which they do. This is ABS. It's super strong. Does what I want it to do. Now at the very end of this video, I'm going to give you a quick demonstration on cutting plexiglass. This is 1/8 inch plexiglass that I used for this. It basically took almost an entire 4x8 sheet to create this, and that's not going to be cheap for you folks. I guarantee you that. But wood right now is not very cheap either, so you got to pick your poison. I like this because when it's sitting here in the corner, it doesn't look like I got a big wooden box with a printer stuck inside. I can see through everything. I've got it backlit with a little desk lamp behind it. Kind of just looks kind of cool. It was there. I plugged it in. That's where it's been ever since. I'm not a home interiors decorator by any stretch. But yeah, it's worked really well so far, and the hinges turned out really well. One thing I will tell you is when you're putting this together, be patient. You got to be patient. Glue only a little bit up together at a time. I had this thing actually fully assembled with no glue holding itself together as is. So then what I did before I put a lid on it, I put all the top pieces together. Once I had all the top pieces up there setting together and leveled out, I let that cure overnight. Then I flipped it over and I worked the bottom. Because once you glue this together, once I've got this all assembled like I have right now, you can't disassemble it. It's locked in place. It's one piece now, just by this design. But the only tool I used to create this was silicone in a tube, plexiglass, a utility knife to score and cut the plexiglass, and a 3D printer. This printer can print all of its own parts to make its own enclosure, which is really cool. And it's not a lot of filament it takes either. and it works really well, and it'll work for years to come. And you're not going to wear it out very easily. It's not like these doors are swinging in the wind all the time. Anyway, had a lot of fun creating it. So happy now I can successfully print ABS with a lot of confidence. I'll put anything in here now. I had bought 7 rolls of ABS of multiple colors. 2 of those rolls were red, but I was like, I want to be able to use this filament somehow. But ABS has some properties I want to enjoy that PLA does not have. As far as this, if I leave it in the car on a hot day, it's not going to turn into a potato chip. Not that I would have this in a car for any reason, but you know, if you have parts in a car, PLA will not take the extreme temperature. It will actually warp and deform and start to melt a little bit in a hot car. So that's where ABS can come into play. I do want to learn a little more about getting this ASA to print, because I do have 2 more spools of that. I want to figure that out. I did print a calibration cube that came out really well in ASA. It's just that was after I had the enclosure, and that's why I went from that to this to that. And so there's an improvement. This may just be a temperature thing. I may just need to run this 5 or 10 degrees hotter on the nozzle temp, and it would work just fine. So we'll play around with that some more. But what else can I tell you? So let's jump over. I'm going to show you how to cut a piece of plexiglass, and that'll be about the end of this video, just so you guys get an idea of what you need to do. And I was scoring and breaking 4-foot wide sheets of this stuff to get my sizes broke down to what you see here. So anyway, let's jump over there and I'll show you that real quick. Now once you have you lay out your plexiglass height where you want to cut it. Now this, I'm just going to cut this at an arbitrary point, doesn't matter, but you want to have a good solid hold down on your straight edge. Use your utility knife, and you only want to make 1 swipe across this thing to score it. So I'm going to drag this across like that to make a score. This is just like cutting glass. Then what I did is, you want to take this edge, and I'll put it right up against this edge here on the edge of the table. Then you just give it a sharp downward push, and it'll pop just like that. Then all that's left to do is cut the paper, and you've cut your piece of plexiglass. It's just that easy. Well, when you're wrestling a big, you want to have a big enough surface like I've got here on this tabletop that you could lay a whole sheet, and I could score and support along an edge, a 4-foot width of it, so you can actually get a nice pop. And now it sounds like a shotgun going off when you pop that glass like that. When you do a big sheet like that, it even scared my dogs. But it works really well. Well, folks, that's the long and the short of printing ABS and being able to print ABS and creating an enclosure. There's lots of great videos out there on printing ABS. I tried many times on a couple of these different machines here to do it with an open, without having an enclosure, and it didn't work out as well. I had trouble getting it to stick to the table, had trouble getting it to not split and crack or deform or warp excessively. Just to give you an idea, here's one. Like, you probably can't see it very well, but this one almost came out, but it split right here, and that hole is really oblong. I printed this laying down like this, and it just really shrunk weird. Now, compared to this one, that hole's perfectly round. Everything just came out just beautiful, like it should. Anyway, probably won't hang on to these very much longer. They just are a good progression of how things went. And got any questions or anything for comments, leave them in the comments. Leave me a comment. I'll respond to all my comments as often as I can, as quickly as I can. And like I said, everything that I have in this video that I used to create it will be a link in the description that will take you to the product that you can purchase it and do something like this yourself. Now, I did see on, except for I won't have a link to the 4x8 sheet of plexiglass, because there's not a lot of places out there that sell 4x8 sheets. I just happened to purchase this like over 9 years ago, and I had it sitting in my garage for 9 years, and I decided to finally use it, and I did. And but the cool part is you can go on Amazon, and this won't be cheap. I was just pricing out some 16 thick 24 by 36 inch stuff, and it was like $22 a piece. So if you're going to do this in plexiglass, I'm guessing it's going to cost you well over $100. in Plexi. But the results are pretty cool, and it's going to probably be cheaper to make it out of MDF or some other inexpensive wood. Personal preference at that point, guys. It really is, in gals. Don't leave the gals out either. But anyway, I had a lot of fun building it. I'm very happy with the results. I am more than head over heels happy about being able to print ABS confidently now. That's a big win in my books. You guys get out there and have some fun, enjoy life, take on some new stuff, try some new things, learn. I learn by doing. I make mistakes, I learn. I make mistakes, I learn. That's just my iterative process, maybe. I hope you enjoyed the Fusion 360 stuff I showed you in this video. Hope it gives you leaps and bounds ahead, because golly, you got to create your own stuff. Now, I say that when I'm printing something I didn't create, but I'm using this as a test because it's got a lot of detail. But I have drawn quite a few things so far. All my printers over here that are running are all running my own creations, my own stuff that I've designed and I'm printing, that I'm doing for giveaways and different things like that. So, you guys, thanks for bearing with me. This is Michael, and I'm out.